Hey, what's up again? It's Greg from Greg's Tutoring NYC. Yo, my email's at the bottom. If everybody wants to hit me up, ask me any questions you want at all. Or if you need last minute tutoring, go for it. Okay, so I just did the 2023-2024 handbook. That's what we're looking at right here. We're doing the Gridins section. So I just did the Form A. We're going to do the Form B Gridins now, okay? Wait, my video is not adjusting right here. I don't know how that's happening. All right, anyway. All right, give me 2 seconds. Just we're going to look and make sure, again, as I said on the other video, if you go to page 26 of your handbook, was it 26? I wrote it down somewhere. Yes, I'm at 25. So if you go to page 26 of your handbook, it'll show you the grid and instructions. Okay, and if you also go to page 267, it actually has some grid examples. And in particular, you want to look at the examples where they actually show you what the gridins are supposed to be for some of these, all right? So that's super duper important because you don't want to be doing all the computations and then getting the gridin part wrong. So let me bring up the B exam and we'll jump into the questions. All right, let's see here. Where is this thing here? All right, there we go. All right, so again, as I said on the other part, read the instructions, make sure that you're really kind of following what's going on. So my modus operandi is always to look at the illustration of a math question first. I find that when I look at the words kind of drag me one way, and then I have to try to force fit the illustration. And I'd rather look at the illustration not quite knowing what it is 100%, and then kind of confirming what I thought with the words. So let's do that. So it says this is a table about last year's sales totals, and it's about vehicles and the number of vehicles sold. So for instance, there was 900 trucks sold, and then the total is 9,000. Hopefully that adds up to 5850, the 2250, the 900 gives you the 9,000. There's really nothing else going on here. I can make some guesses what the question might be, but I don't really want to go there because I want to look at the question and answer it now that I understand the table. The goal of the looking at the table wasn't to second guess the question. It was to understand what is the data they're providing to me. And I'm also looking in case there was a caption, like the top caption, or a legend or a key saying every car represents 5 cars or every car represents 1,000,000, right? This is what I'm looking for on the charts and the tables. Make sure I know the scale. If this was something about inches and feet and yards, I want to make sure my head's screwed on right. If it's a geometry question and it looks like a circle, I want to know when they get to the words, they tell me it was a circle, and so on and so on and so on. All right. So it says the table above shows the number of each type of vehicle, that's these here, okay, sold at a dealership. If 1,000 vehicles were sold next month, right, this is representative of 9,000, but if 1,000 were sold next month, what is the best estimate based on last year's sales? That's what this was about last year, okay, of the number of two-door cars sold. All right, so last year, what they're asking us, we need to set up a ratio. It's 2 doors to all of them. All right, the total. So the ratio of 2 doors to all of them was 2250 over 9,000. Okay. So they're asking us, and that's our conversion ratio, if you will, right? A lot of you guys memorize unit conversions of different kilometers to millimeters and gallons to pints and all this other stuff. Well, this is a user-defined user conversion. That's the ratio, the rate. The rate is for every 2-door car, the total, right? So 2250 is to 9,000. All right, 9,000 is the number of cars sold, and 2250, and we're going to get our ratio there. Now, we could simplify that if we want, okay? Or I realize that if this is going to be my rate, all I really need to do is now multiply it by the actual number they're shooting for, the 1,000 here. So if I multiply that by 1,000, what's the same as 1,000 over 1? I'm basically going to get to 2250 times 1,000 over 9,000. Well, that means these three zeros can cancel those three zeros. And really what I'm getting is 2250 over 9. Okay? And that's what we need to solve. All right, so that might leap out at you, or you just go to the division, 9 into 2250. Okay, 9 goes into 22 two times. That's 18. We're left with 4 left over. 9 goes into 45 5 times, and 9 goes into that last 0 0 times. So our answer here is 250. Okay, and we can use numeracy and kind of make sense of it. So that means there's 250 two-doors out of 1,000 cars. So if the other original scale that we're using is a 9,000, right, we can do a back of the envelope thing and say, well, if it was 2,000, that's 18. It was 3,000. Sorry, if it was, instead of this 250, we said it was 200. We would get about 1,800, and if it was 3, we would get 2,700, and that's about within the scale of the magnitude of this thing here. Okay, so that makes sense. We got it. Okay, 59 is a scale. Okay, this also usually means it involves a rate as well. All right, so we need to figure that out. Right, a scale. Scale implies there's going to be a rate. So usually we're going to set up a scale. Okay, if the length is 15 inches and the width is 9. So we have a rectangular garden. We should usually try to draw it. So it says in a scale drawing of a rectangular garden, the length is 15 inches and the width is 9 inches. So when I do these, I'm looking for your unit conversion as well, because on top of it, they may ask us to do something with that. So in the drawing, 2 inches represents 3 yards. All right, so that's my rate. 2 inches is the 3 yards. So they're asking us, what is the width of the actual garden? So in this case, all we really need to do is set up a proportion. We know the width is 9 inches, and they're asking us how many yards is it. So all we have to do is set up a proportion, and then just do the cross product at that point. Okay, so we get the 2 times the x, so 2x, and then the 9 times the 3 is 27. Okay, divide both sides by 2, that cancels. Divide that by 2, right? And then we get 13.5 yards, right? So because the scale had the conversion built into it, x, because we did inches is to yards, 2 inches is the 3 yards, 9 inches is to x yards. So our answer when we solve x, it's going to be in yards. All right, so that's what we get, yards. And then we can think it through. Does that make sense? If 2 inches is 3 yards, does it make sense that way we get something, a number along those lines? Yeah, it does. Okay, so that jives as well. Okay, a kindergarten teacher has 72 crayons, 60 pencils, and 84 sheets of paper. So we have 72 crayons, 60 pencils, and 84 sheets of paper to distribute to the children in the class. If each child receives an equal number of each item and there are no items remaining, so it divides perfectly. They all get equal and there's nothing left over, so it's a perfect division. What is the greatest possible number of children in the class? So this comes up often. When you see something like this, a lot of students don't know how to solve this. There's usually 3 things you need to think of for the solution mechanism here. One is the GCF, the greatest common factor. The other is the least common multiple. And the other is related, which is it might involve factors somehow. Okay, so they kind of gave us the 72, the 60, and the 84. All right, so this turns out to be a GCF question. This is the greatest common factor of, and if we write it out symbolically, 72, 60, and what's the last number? 84. We can kind of do it that way. Now, there's a few ways to get to GCF. I like to use the ladder method, LEDDER. What you do is you write out the three numbers, 70, 60, and 84. What you start doing is you find the smallest prime number that goes into all these evenly. All right, I wrote 70 there. That should have been 72. So the first one is 2, so we get 36. We get 30. And we get what? 42 there? Okay, so it turns out we can do it again. This the lowest prime number again. So 2 goes into 36 18 times. 2 goes into 30 15 times. 2 goes into 42 21 times. All right, so 2 no longer works, but 3 goes into each of these. So 3 goes into here 6 times. 3 goes into here 5 times. And 3 goes into here 7 times. There's no longer any number, any prime number that can go into these because they're all unique at this point. So we're done. And by the way, when you use the ladder method, there's 2 things we can do. The first is if I do this L shape, these 3 numbers and these numbers, multiply them, that's the LCM. The GCF is just these 3 numbers multiplied against each other. So 2 times 2 is 4, times 3 is 12. Right? And that's our answer. And I like this because I can get the GCF and the LCM together if you need to, because there's some questions where you do need to. All right. I also like it because it's compact. You can also use prime factorization to do this, but I find students start making silly errors because you can also do that to get the GCF, and there's different rules for each. Okay. Anyway, you keep dividing on this side here, the left side, by the smallest prime number possible that can get into each of these, and you stop when there's no divisors left. That's common to all 3 of them. And then that left column, you just multiply out. All right, so the first insight was that this was a GCF question. And again, use those 3 when you're kind of stuck on some problems, especially when it's involving multiple numbers, or it looks like there might be a multiple involved here. Okay? So if you think it through, where did the 12 come from? Right? Well, 12 times 6 is 72. 12 times 5 is 60. Right? 12 times 7 is 84. So that they were asking, what is the greatest possible number in the class? If the distribution of those little supplies, the crayons, the pencils, and the paper, were able to go to all those different students. Right? We can get the multiples of it. I just did the multiples of it, so it works out. All right, so that one wasn't too bad. Okay, the video just before this, I also did simple interest. So if you remember, simple interest was equal to the principal times the rate times the time. So Mr. Smith opened a retirement account with a deposit of $900. That's the principal. The account earns 5%. So that's the rate. 5 of 100. Okay. Simple interest. It's not compound interest. How many years will it take for his $900 deposit to own $360? They're telling you the interest. So this is being set up exactly the same as the other one, because the other one we had to compute the time as well. So times t. So we're going to solve for t. I did the other one forward. I'm going to do this one backwards, just to show the 2 different ways of comparing how to do these. The math is the same underneath it either way. So I'm not going to compute anything yet. So we're going to notice that if we just rewrite this quickly, 360 is equal to, the numerator is going to be 900 times 5 over 100. Okay, and that's times t. So to solve for t, we basically need to multiply each side by 100 over 900 times 45. So we can do that and come over here. So we have 100 over 900 times 45. All right, this cancels that, that cancels that. So we have t on that side. And then we can do a whole bunch of stuff here. We know that these two zeros here can cancel that. All right, so we have 1 over 9 times 45. All right, it should leap out at you that 45 can go into 360 a whole bunch of times. We also know that 9 can go into 360. So either way works. 45 times 2 is 90, and 90 times 4 is 360. So 45 goes into there 8 times. All right, so there's a whole bunch of meandering gymnastics we can do here. Okay, so at the end of the day, we get 8. So again, the 9 here, if let's do it the harder way, 9 can go into here 40 times. Let me see. I wrote something backwards. What did I write backwards? I wrote 45. It should have just been 5. And then 5 goes into this 48. All right, so I made a mistake in copying this. I wrote over here 900 times 45. It should have just been times 5. The same thing over here. So we divided it. It should have been divisible by 5. All right, and then the 9 goes into there 40 times, and then the 5 goes into there 8 times. So if you look at all we canceled out, 8 is equal to t. Okay, and we can plug it in, work it backwards to do your double check. Don't always leave questions. Stop. The X means stop, and make sure you're reading things. So you want to do 2 things. One is you want to read the question. That's the actual literal question of the question number 61 here. And then feed it back into the whole question, the whole paragraph. Okay? 62 creates a big catastrophe for a lot of students because there's a few things that kick out from it that you guys kind of should know. So you don't really need to do those multiplications. You can cancel out stuff if you want, and there's multiple cancelings out. Another thing you guys should know is that this here, you should know that that's 7/8. You should automatically know that that's 7/8. All right, if you do, it makes the problem a lot easier. Anyway, what you want to do is analyze this guy here and see what can cancel out on that thing there instead of doing the ugly multiplications. So it should kind of leap out at you that 7 is involved here. 7 can go into 49, into 14, and into 21. All right. So let's do 7 into 49 7 times here. And at this point, we could do it into the 14 or the 21. 7 goes into here 3 times. Okay. Many of you don't know that 16 times 3 is equal to 48. You should know it. This comes up a lot on exams, including the SHSAT. Okay. If you did it the other way, we could have did 7 into the 14 and got 2 and did cancel that another way. Anyway, the 3 goes into 3 once, and 3 goes into here 16 times. All right. And we can still cancel, right? 2 goes into here 7 times, and 2 goes into here 8 times. All right. And then the 7 cancels the 7. So basically, in the end of the day, we get x over 8 is equal to 0.875. Now, if you know, as I said before, that's equal to 7/8, then obviously the x is equal to 7. Otherwise, what you need to do is, if you don't know that, that means we're ignoring that. You need to say, to multiply this by 8, so that would cancel, which means we have to do x is equal to 0.875 times 8. That's an ugly multiplication. But at the end of the day, when you do it, that's supposed to be equal to 7. Right? So we can do 0.875 times 8. 8 times 5 is 44. That's 7 times 8 is 56 plus 4 is 60. 0. Carry my 6. 8 times 8 is 64, plus 6 is 70, right? And we have 1, 2, 3 decimal places here, 1, 2, 3 decimal places here, right? But if you know certain things like that, you're done with it, okay? And speaking of done with it, that's the last grid-in question. So I'm going to do some more of these with multiple choice and figure out how to fit in some of the ELA into all this as well. All right, guys. Wish you guys a great day. Peace.